Hello everyone, Zaid from Z Security here, and in today's video we're gonna talk about the most secure operating system in my opinion. I'm gonna explain to you how it works, why it's more secure, and then I'm gonna give you a demo on how it works and show you how we can use it to safely open files even if they contain viruses and malware. Show us some love by smashing that like button, share the video, subscribe to the channel, and hit the bell if you haven't done so already. We can argue that any operating system, including Windows, can be hardened and made more secure. Replace Windows with a hardened Linux and a well-educated user, and you should be relatively secure. I'm saying relatively secure because we can do better. See, the main problem with all operating systems is that everything runs within one space. Therefore, if you get hacked, regardless of how you got hacked, all of your data will be exposed. A good solution to this problem that can improve our security is to use different computers for different tasks. For example, use one computer for work-related tasks, use one computer for your personal-related stuff, use another one for the untrusted stuff whenever you're just browsing through websites and opening attachments and so on. Use one computer that is not connected to the internet to store your passwords and keys. This way, if somebody manages to hack into one of these computers, they'll only get access to one computer, and it'll be very difficult for them to move from this computer and compromise the other computers. Not only that, but the fact that you have an untrusted computer that you don't do any personal or work stuff on means that this will be the computer that will probably be hacked, not the other ones. So all of your important stuff in work and personal will not be hacked, and the hackers will not be able to gain access to them. Also, if you're using a separate identity on this untrusted computer, then your real identity or the identities that you use on work and personal, again, will not be compromised. So this is a really good solution. The only problem is it's not cheap. You need a number of computers, and it's also not easy to achieve. So imagine having to use a different computer every time you want to do a different task. You can make this slightly easier and use one computer, but use multiple USB sticks, and again use each one of them for a separate domain, one for work, one for personal, one for untrusted. But again, this is not very usable because let's say, for example, you are using the work USB stick and you opened your work email, you're reading an email and there is an attachment, and you really want to open that attachment, but you can't really trust that attachment because it could be anyone. It could be a hacker pretending to be a friend, or it could be someone who gained access to your friend's account. So if you want to follow this model and if you want to be secure, you need to boot into the untrusted distro or the untrusted USB stick and open the attachment there. Then once you open it and read it, if it's fine, you need to turn this off, boot back into your work USB stick, your work domain, and then reply to the email. So you can see that if you're doing this every day, it's not very practical and it's going to become very annoying. This is where the idea of Qubes came from. Qubes is an operating system that is designed to improve security by compartmentalisation. So as soon as you boot into this operating system, it boots into Zen, which is a hypervisor, and then once the operating system starts, everything inside this operating system is separated into different domains. You'll have a domain for work, a domain for personal, an untrusted domain, and so on. And each one of these domains is a completely separate virtual machine. So you can think of these virtual machines like completely separate computers, and hence the name virtual machine. So each one of these virtual machines has its own RAM, its own CPU, its own file system, and so on, and is completely unaware of the other virtual machines. So just like running different computers, if your untrusted virtual machine or the untrusted domain gets compromised or hacked, it is very difficult for a hacker to move from there to your work or to your personal virtual machine. Not only that, but Qubes also separate other system components into virtual machines. So you have your networking, your file system, your USB controller, and your firewall all running inside their own virtual machines. So if a hacker manages to exploit a vulnerability in any of these components, then only get access to this isolated virtual machine that is not even aware of the existence of your work and your personal domains and so on. And with this, you won't need to have multiple computers, and you won't need to keep restarting and booting into different USB sticks. You'll always be using the same operating system, and the different virtual machines will be running inside this one single operating system. Now, these amazing features come at a price. Qubes is very resource hungry and has very specific requirements. I will include a link to this list in the documentation along with the installation steps. I actually cover installing and using Qubes in details in my privacy, anonymity, and security course, so check it out if you want to learn more about Qubes and about how to protect your privacy, anonymity, and how to access the dark web securely. Now let me give you a quick demo to give you a better idea on how Qubes works and how it can improve our security. Stick to the end to see how we can use it to open files safely even if they contain backdoors or malware. So this is what the desktop looks like, and you'll probably notice that it looks like a normal Linux desktop. I don't want to waste a lot of time talking about every single component. I talk about that in my course. I want to dive straight in, and I'm going to click on the top left menu, the applications menu. Each entry in here is actually a virtual machine, and then each one of these virtual machines contain different applications that you might want to use. Basically, a virtual machine is another completely separate operating system that runs within our current operating system, within this computer right here. So each one of these entries in here is another operating system, and hence the name virtual machine. It is as if it's a completely different computer. It has its own storage, its own RAM, its own CPU, its own resources, and therefore this implementation is very, very secure because none of these virtual machines can communicate with each other. So if one of them gets hacked, or an application that is stored in one of these virtual machines gets hacked, it will not be able to compromise the other virtual machines. Now you'll notice there are different types of virtual machines in here. We have disposable virtual machines, domain, service, and template. The disposable virtual machines are amnesic virtual machines. So these machines are designed to be used to run untrusted files, or files that you think might be malware or viruses, because once you run these files in them, even if these machines get hacked, the virus or the backdoor cannot move, or the hacker cannot move and compromise other machines, because like we said, everything is a completely separate machine. Not only that, once you turn off this disposable machine, everything that was stored on it, including the virus or the backdoor, will be removed. So when you start it again, it will start a completely brand new machine. Next, we have the domain virtual machines, and you can see these have different colors. And the idea of these machines are normal computers or normal virtual machines that can be used for normal usage. So you have one that's called personal. You should use this for whatever personal use you use a computer for listening to music, watching YouTube, watching my videos, whatever you usually do on a personal computer. You have an untrusted domain. This is a virtual machine that is designed for you to do untrusted things. For example, doing the normal web browsing. If you are searching for something and you're not sure if you're gonna land in an untrusted website, then you can use this untrusted machine. Don't open your email or any accounts on this because it's untrusted. You're gonna be doing untrusted tasks and opening untrusted websites. Therefore, even if this machine gets hacked, your personal data on your personal computer will not be compromised because they are two completely separate virtual machines. We have a vault domain, and this domain is a virtual machine that is not connected to the internet. And the whole idea of this is you store your most important and most secretive files or data. So you can store your secret keys, you can store your passwords, you can store documents that are very important and you can't risk them being leaked. And again, the whole idea is this is not even connected to the internet, and it's a completely separate computer, a completely separate virtual machine. Therefore, it is very, very, very difficult or next to impossible to hack into. Finally, we have a work domain. Again, this is just another virtual machine that is designed for you to use for your work tasks. So you can open your work email, you can log into your work if your work needs you to log into a certain platform. And again, this is a completely separate virtual machine. So if any of the other machines get compromised, your work, whatever you have in this virtual machine, will not be compromised because it is a completely separate virtual machine, a completely separate computer. Now you're probably thinking this is going to be very annoying if you're going to be running different applications in different operating systems. The idea of virtual machines is actually not new anyway, but the cool thing is the experience that Qubes provides. It is very, very seamless, and you'll be able to use these applications as if they're normal applications in normal Windows, but they are in fact running in separate virtual machines in the background. Let me run some applications and I'll show you what I mean. So let's go to the personal virtual machine or the personal domain, and let's click on Firefox because we want to access the internet. And you'll notice here on the top right, it's going to say that it is starting the personal virtual machine or the personal domain. So the first time you launch an application within a domain, you'll notice that there will be a little bit of a delay. The reason for this is, like I said, each domain is its own virtual machine. So the first time you launch an application within that domain, the first thing that Qubes will do is start a virtual machine, start a completely separate computer, and then launch the application that you requested within this domain, within this new virtual machine. Once done, as you can see, you'll get your application, which is Firefox in this case, and let's see if it's connected. So let's go to Z Security. And perfect. As you can see, we have a normal internet access. Everything is working as expected, and you can use this browser the same way that you use any other web browser. Now, let's go ahead and go to the personal again, and this time I'm going to launch my files. And you'll notice that this will be almost instant because the virtual machine is already running. Therefore, I can open the file manager within that virtual machine, so there is no need to start the virtual machine from scratch. Now, let's put this here to the side. And what I'm going to do is I'm going to go back to my applications. And this time, we're going to go to the work domain or to the work virtual machine. And again, let's go ahead and launch a Firefox instance. Now again, this is the first time we launch Firefox from within the work domain. Therefore, this will take a bit of time to boot the work virtual machine first and then open Firefox. And perfect. As you can see, we have Firefox running in here. And let's go to Google this time. And as you can see, we have internet access. Now, keep in mind, this window right here, the Firefox window, the blue one, it is a completely separate virtual machine than the yellow window right here. This is a work computer, a work virtual machine, a work domain that is completely separate from the personal domain. Therefore, if this personal domain gets hacked or if the work domain gets hacked, the hacker will not be able to navigate to the other domain because these are two completely different and isolated virtual machines. They use their own resources, they use their own RAM, their own CPU, their own file system. So it's as if you're running two different instances of Firefox on two completely different computers. This design is really nice in my opinion because it is seamless. You don't actually see new desktop every time you launch an application. You only see the application window and the color indicates what security domain or what virtual machine you're running in. Now, before wrapping it up, I want to show you how we can use the disposable virtual machines to interact with untrusted files without compromising our security, even if these files contain viruses or malware. The whole idea is when you start a disposable virtual machine, Qubes will create this virtual machine. Unlike what happens with all of the other machines, Qubes will start an existing machine. In the case of the disposable virtual machine, when you start one, Qubes will create a new virtual machine. You will use it, and then when you're done, when you turn it off, Qubes completely destroys this machine. So the next time you start a disposable machine, you will start a completely new virtual machine. So, hovering over this, just like any other virtual machine we have inside Qubes, you can see that we can launch a number of programs, mainly Firefox and the terminal, and then you can enter the Qubes settings. This is pretty much everything you'll need. So for example, let's say you're using your work virtual machine right here. So I have a Firefox instance in my work domain, as you can see here. And the email could ask you to click on a link. Now, clicking on this link could result into you getting hacked, but at the same time, because you trust this address, you actually want to click on the link. So the best solution for this is to go and start Firefox inside a disposable virtual machine. Like I said, this will create a completely new virtual machine, and inside this completely new virtual machine, it will start a Firefox instance. And perfect, as you can see, we get a normal Firefox browser. So what you want to do is, let's pretend that this is the email that you got. All you'll have to do is copy the link that you want to open. You don't want to open it in here. You just want to click on copy link location. This will copy it within the clipboard of this virtual machine of the work domain. So you'll have to do Ctrl-Shift-C to put it in the global clipboard. Go to the virtual machine where you want to paste it. Again, I covered this in details before, so I'm doing it quick. If you don't remember how to do it, go and revise that lecture. So we go to the virtual machine where we want to paste this text. We're going to do Ctrl-Shift-V to paste it in the clipboard of this virtual machine, and then Ctrl-V to paste it in my URL in here, as you can see. And I have the link right now in here, so all I have to do is just hit enter. And that'll load the link for me inside this completely isolated disposable virtual machine. So let's assume that this link exploits some kind of a vulnerability that will allow the hacker to hack into my computer. They will gain control over this disposable virtual machine, but they won't be able to exit out of it and do anything else. And then as soon as I click on the X in here, the whole virtual machine will be shut down and it'll be destroyed. So the next time I run a disposable virtual machine, I'll actually be running a completely new virtual machine that does not contain the malware, even if it was downloaded using the previous session. So that's really cool, but it doesn't stop there. Let's assume that you really want to open this file, but at the same time, this file is downloaded from the internet or from an email, so you can't really trust it. So if you really want to open this file, all you have to do is right click the file. Instead of clicking open with LibreOffice, you want to go to view in a disposable virtual machine. Clicking on this will create a completely new virtual machine like we've seen before, and then opens the file inside this disposable virtual machine. And once you close it, the whole virtual machine will be destroyed, the file will be removed from the virtual machine, and even if the file contained malware, the malware will not be able to exit that virtual machine and affect your work computer in here, because again, they are two completely separate operating systems. Now, I'm not going to show you that because it's very simple. All you have to do is literally click on view in a disposable virtual machine and it'll work as expected. What I really want to show you and what I think is really cool is the edit in a disposable virtual machine option. So with this option, again, it'll create a new disposable virtual machine, but it'll open the file for editing for me. This way, not only I'll be able to read the file, I'll also be able to edit the file, save it, make changes to it. For example, if I was asked to fill something or to sign the file, I'll be able to do that. So for example, let's just type test.
And I'm going to do Control S to save it. We'll keep it at Microsoft Word 97 format. And now I can go ahead and send this file back, knowing that even if this file contained malware, it did not affect my domain. And if this wasn't enough, there is another really cool feature that you can do for images and for PDFs. This really cool feature allows you to not only view the file in a different disposable virtual machine, but you can also convert the file to a trusted PDF. Let's assume that you have a PDF that you really want to run. What you can do is you can right click and view in a disposable virtual machine. That's fine. Or you can click on convert to a trusted PDF. What this will do is it will first of all create a new disposable virtual machine. It will copy the PDF to this new virtual machine. It will use a complex process in order to make sure that the PDF contains no malware, and also completely destroy the PDF and convert the data in this PDF into images. At the end, you'll notice we have a new file in here. This is called sample.trusted.pdf. So it added the word trusted to our PDF. And this PDF right here is a completely clean version of the original PDF. So not only that we can open this PDF in our current domain safely, knowing that it contains no malware, but you can also go ahead and send it to others. So let's assume you need to send this to a colleague or to a friend, but you're not sure if this PDF is clean. Then this way you can clean the PDF and make sure that it contains no malware. Now, if you're a programmer or considering to learn programming, then I highly recommend checking out Kite. It's an add-on that you can add to pretty much any IDE or text editor, including Sublime, which is my favorite, and it'll pretty much transform it into an IDE, showing you function signatures, documentation, possible methods, and so on. But the coolest thing about it is it'll study your programming style and use machine learning to auto-complete your code. It's really cool. You have to try it to see it for yourself. Just use the links in the description to get it. Kite is sponsoring this video, but I wouldn't recommend it if I didn't like it and didn't use it myself. Now, I hope you found this video useful. Let me know what you think in the comments. Don't forget to like the video if you enjoyed it and subscribe to the channel to stay updated with the latest in cybersecurity.